Hello, Dr. J here. Today I'm going to give a tutorial on oscilloscopes. And here on the right shown is an oscilloscope, and it represents one of the most important EE tools found in the labs. And the primary purpose of the oscilloscope is to see signals that change with time. Also, it may be used to explain why an LED or light emitting diode used in a 555 timer may not be blinking. So oscilloscope serves as one of those tools to figure out, to help you troubleshoot what's inside a circuit. Some of the basics associated with oscilloscopes, as I mentioned before, provides a two-dimensional graph of a time-varying electrical signal. So here we have a time-varying signal called a sinusoid. We have the x-axis shown here representing time and the vertical axis representing voltage. So what can scope measure in terms of time? One of them, it can measure the frequency and the period, and they are reciprocal relationships, meaning that frequency is equal to 1 over the period, or the period is equal to 1 over the frequency. Here I have a square wave shown in red where it displays 1 cycle of its waveform. You can also measure the duty cycle. For a square wave, it's 50% duty cycle, where it's 50% high and 50% low. Then finally, since signals cannot change instantaneously, there's a rise time and a fall time shown here. In other words, going from a low point to a high point represents the rise time, in which the signal must change going from, let's say, 0 volts to 5 volts in a smooth fashion, whereas the fall time is just the opposite. The rise time and the fall time are important characteristics because they tell how fast a circuit can respond to a fast-changing signal. So what can the scope measure in terms of voltage? In terms of the vertical axis, it can measure amplitude. It measures the magnitude or strength of the signal. Here you could see what we have is the peak-to-peak voltage, which basically shows you the dynamic range of the signal, or it can measure the peak voltage on both the positive and negative side. We can also measure the maximum and minimum voltage in the signal, as well as observing the mean and average of the voltage signal. So in this case, we have a mean of 0 since this is the 0 axis. So when do you use an oscilloscope? Well, one is to basically troubleshoot a malfunction circuit by testing the signal frequencies and amplitudes at various points in a circuit. Another is to check the amount of noise that exists in your circuit, as well as identifying the signal shape as you go through the circuit at various points. And then finally, you can calculate the phase difference. So if you send a signal that has a peak that's located here and it returns, let's say a short time later, say here, you can measure the time difference, and in this case measure the phase difference as well, so that you can determine, for example, how far a satellite or target is from your location.